I've been avoiding telling you this story because honestly, it kept me up at night when I first learned it. And I'm not even exaggerating when I say that once you understand what I'm about to explain, you're gonna see the world differently. And not in a good way necessarily, because what Oppenheimer discovered about atoms when they lose control is the kind of knowledge that changes you, and he knew it, and it haunted him for the rest of his life. And here's why this matters to you, sitting there right now, watching this. Every single atom in your body is holding something back, something that, if released, would be catastrophic. And I mean that literally, not metaphorically. And the crazy part is that Oppenheimer figured out exactly how much and exactly what happens when that control breaks. And when he saw the numbers, when he really understood what was trapped inside ordinary matter, he went pale, and his colleagues said he looked sick. And one of them asked him what was wrong, and Oppenheimer just said, "We shouldn't be able to do this." And they asked, "What do you mean?" And he said, "Release this much energy from something. This small nature doesn't want us to have this." And yet here we are. And if you're the kind of person who wants to understand what really lives inside the fabric of reality, hit subscribe right now, because what I'm about to show you is gonna mess with everything you thought you knew about the physical world. And I'm not talking about abstract physics. I'm talking about what's happening inside your hand right now, inside the phone. You're holding inside every piece of matter you've ever touched. And Oppenheimer saw it first, and it destroyed him. So here's what they teach you in school. They show you those diagrams of atoms with electrons orbiting like little planets around a nucleus. And they tell you atoms are stable, and they tell you matter is solid and reliable, and for most purposes, that's fine. That's a useful lie. But then they mention in passing, oh, by the way, there's energy in atoms. And you think, okay, sure, like batteries have energy and food has energy. No big deal, except here's what they don't tell you. Or they do tell you, but they say it so casually that you don't process how insane it actually is. The amount of energy inside a single atom is absolutely out of proportion to its size. Like, it doesn't make sense. It violates every intuition you have about how the universe should work. And I'm going to give you real numbers here. So you understand, I'm not exaggerating. If you take 1 kilogram of matter, just 1 kilogram, that's about 2 pounds. That's like a bottle of water. And if you could convert all the mass in that matter into pure energy, you know how much energy you'd get? 90 quadrillion joules. And I know that number means nothing to you, so let me translate it. That's the energy equivalent of 21 megatons of TNT. That's 1,400 Hiroshima bombs from 1 kilogram from 2 pounds. And Oppenheimer knew this. He calculated this. And here's the problem. That energy is just sitting there. It's not theoretical. It's real. It's trapped inside the structure of matter itself, held in place by forces that are barely keeping it together. And when those forces break, when atoms lose control, that energy comes out all at once. And Oppenheimer realized we could make that happen. We could trigger it on purpose. And that's when everything changed. Because up until that point in human history, violence had limits. You could only destroy as much as you could physically reach with your hands or your weapons. But Oppenheimer discovered that inside ordinary matter, there's enough violence to erase cities, to vaporize hundreds of thousands of people in seconds, to poison the earth for generations, and all you have to do is figure out how to make atoms lose their grip. Now I need you to really picture this, because this is where it gets wild. Close your eyes for a second, and imagine you're holding an atom in your hand. I know you can't actually do this, but just visualize it. You're holding something so small that if you lined up 100 million of them side by side, they'd be about 1 centimeter long. That's how tiny we're talking. And inside that atom, there's a nucleus at the center. And the nucleus is even smaller if the atom was the size of a football stadium. The nucleus would be a marble sitting at the 50-yard line. That's the scale we're dealing with. And inside that marble, inside that nucleus, there are protons and neutrons packed together, and they don't want to be there. They're pushing against each other with incredible force, because protons are all positively charged, and positive charges repel each other, right? You learned that in school, like charges push apart. So imagine you're trying to cram a bunch of magnets together with the wrong ends. Facing each other. They're fighting you. They want to fly apart. And that's what's happening inside every nucleus protons trying to escape. And the only thing holding them together is another force called the strong nuclear force. And it's the most powerful force in nature. But here's the thing. It only works at extremely short distances. Like if the protons drift apart even a tiny bit, the strong force stops working, and the electromagnetic repulsion takes over, and the nucleus explodes. And when I say explodes, I don't mean like a little pop. I mean it releases energy on a scale that doesn't exist anywhere else in normal human experience. And Oppenheimer understood this better than almost anyone. He calculated exactly how much energy was being held back. Exactly what would happen if that barrier broke. And he realized something terrifying. You don't need much. You don't need to split every atom in a chunk of matter. You just need to split enough of them to start a chain reaction. And here's how that works. When you split one uranium nucleus, it releases energy. Yes, but it also releases neutrons. These are particles that were inside the nucleus, and now they're flying out at incredible speeds. And those neutrons can hit other uranium nuclei and split them. And each of those releases more neutrons, and those hit more nuclei, and you get a cascade, an exponential explosion of splitting atoms, each one releasing its trapped energy. And if you do this with 1 kilogram of uranium-235, and you get a perfect chain reaction where every split atom causes another split. You know how long it takes for the entire kilogram to explode, less than 1 microsecond. That's 1/1,000,000th of a second in less time than it takes for a single thought to form in your brain. You go from solid matter to a fireball hotter than the surface of the sun. And Oppenheimer knew this. He could see it in the equations. He could predict it. And he also knew that once you figured out how to trigger it, once you built the UCDO mechanism, there was no putting it back. You couldn't unknow it. You couldn't uninvent it. And that's what ate at him. Let me give you another way to think about this, because the numbers are so big, they stop meaning anything. Here's a thought experiment. Imagine you're in a room, and in the middle of the room, there's a soccer ball, and someone tells you that soccer ball contains enough energy to power every home in a city of 1 million people for an entire day. And you'd say, that's impossible. Where's the energy stored? Batteries, no fuel. No, it's not glowing, it's not hot, it's just a ball. And they say, the energy is in the mass itself, in the structure of the matter. And you say, okay, prove it. And they say, we can't actually extract all of it. We don't have technology that efficient, but we can extract some of it. And they take a tiny piece of the ball, a chunk the size of your fist, and they put it in a special device, and they trigger a chain reaction. And that fist-sized piece releases enough energy to level everything within a 5-mile radius. And you're standing there watching this, and you realize, holy shit, the ball was always capable of this. The energy was always there. I was just holding it, like it was nothing. And that's what Oppenheimer felt when he looked at ordinary matter. He saw the violence trapped inside. He saw that every object, every person, every building is essentially a frozen explosion, held together by forces we barely understand. And if those forces fail, if atoms lose control, the energy comes out, and there's no stopping it. And here's what really got to him. It's not hard to make atoms lose control. Once you know the trick, uranium is naturally unstable. It wants to split. You just have to give it a little push. You have to arrange it in a certain shape. You have to bring enough of it together, so the neutrons from one split atom are likely to hit another. And boom, you've got a chain reaction. And Oppenheimer figured out the exact specifications. He calculated the critical mass. That's the minimum amount of uranium you need to sustain a chain reaction. And for uranium-235, it's about 52 kilograms, about 115 pounds. That's all you need, less than the weight of an average person. And if you compress it, if you use conventional explosives to squeeze it into a denser ball, the critical mass gets even smaller. And with that amount, with that design, you can release the equivalent of 15,000 tons of TNT from something you can carry. And Oppenheimer built it. He led the team that turned this theoretical knowledge into an actual device. And on July 16, 1945, at 5:29 in the morning in the New Mexico desert, they tested it, and it worked. And he watched the fireball rise, and he thought of a line from Hindu scripture. Now I am become death, the destroyer of worlds. And people ask, why did he quote that? Why that specific line? And the answer is, because he understood what he'd done. He'd figured out how to make matter betray itself, how to unlock the violence that's been locked inside atoms since the beginning of the universe. And while you're processing that heaviness drop, a comment telling me where you're watching from, because I'm genuinely curious where in the world people are who want to understand this kind of thing. And now let me tell you the most disturbing part, the part that Oppenheimer couldn't escape. See, when you split an atom, you're not just releasing energy, you're also creating new elements, radioactive isotopes that didn't exist before. And these isotopes are unstable. They're trying to become stable again. And the way they do that is by emitting radiation. And this radiation can tear through living tissue. It can shred DNA. It can cause cells to mutate or die. And the half-lives of some of these isotopes are insane. Like strontium-90 has a half-life of 29 years. Cesium-137 has a half-life of 30 years. Plutonium-239, which is created in nuclear reactions, has a half-life of 24,000 years. That means if you detonate an atomic bomb, you're not just destroying things in the moment. You're poisoning the environment for generations. People who weren't even born yet will suffer the consequences. And Oppenheimer knew this before Trinity, before Hiroshima, before Nagasaki. He knew that what they were building would kill in ways that conventional weapons never could. It would kill people who were miles away from the blast. It would kill people years after the explosion. It would seep into the soil and the water and the food chain, and there was no way to clean it up, no way to take it back, and he did it anyway. And that's what haunted him. Not just the immediate deaths, though. Those haunted him too. 140,000 people dead in Hiroshima, 70,000 in Nagasaki, most of them civilians vaporized in an instant, or burned or crushed, or slowly dying from radiation. But what really got to Oppenheimer was the knowledge that he'd opened a door that could never be closed. He'd shown humanity how to weaponize the fundamental structure of reality. And once that knowledge existed, once other countries saw that it was possible, they'd build their own bombs. And they did. The Soviet Union tested their first atomic bomb in 1949, just 4 years after Trinity. And then came the hydrogen bomb, which is even worse. It uses atomic bombs as triggers to fuse hydrogen atoms together and release even more energy. The first hydrogen bomb test in 1952 released 10 megatons of energy that's almost 700 times more powerful than Hiroshima, from a device that wasn't even that much bigger. And Oppenheimer opposed the hydrogen bomb. He argued against it. He said, "This is madness. We don't need this kind of power. No, war requires this level of destruction. And they built it anyway. And they stripped him of his security clearance in 1954, in a hearing that was basically a show trial. They questioned his loyalty. They brought up his communist associations from years before. They humiliated him publicly. And he sat there and took it. And later someone asked him why he didn't fight back harder. And he said, "What would be the point? The bomb exists. The knowledge exists. I can't undo what I've done." And that's the thing about what Oppenheimer discovered: once atoms lose control, once that chain reaction starts, you can't stop it. The energy comes out, whether you want it to or not. And the same is true for knowledge. Once you know how to do something, once you've proven it's possible, you can't unknow it. Now here's where this gets personal to you, because you might be thinking, okay, this is about bombs, this is about weapons, this is history. But it's not just history, and it's not just weapons. What Oppenheimer discovered about atoms losing control applies to every atom everywhere, including the ones inside you. Right now, your body contains approximately 7 billion atoms. That's 7 with 27 zeros after it. And every single one of those atoms is holding energy the same way. Uranium atoms hold energy. The difference is that your atoms are stable. They're not going to spontaneously split. They're not going to chain react. But the energy is still there. The mass-energy equivalence that Einstein described, and Oppenheimer weaponized, that applies to everything. If you could somehow convert all the atoms in your body into pure energy, you'd release the equivalent of several thousand atomic bombs. You are essentially a walking stockpile of unimaginable power held together by forces that just barely keep you from exploding. And Oppenheimer saw this. He saw that the line between matter and energy is thinner than anyone imagined. He saw that what we call solid reality is just energy in a temporarily stable configuration. And he saw that human beings had figured out how to destabilize it, how to tip atoms over the edge and release what's inside. And that knowledge changed him. People who knew him before the war said he was arrogant, confident, sure of himself. People who knew him after said he was haunted, quiet, burdened, and it's because he'd seen something most people never see. He'd seen the violence inside peace, the destruction inside creation, the end inside the beginning, and he couldn't unsee it. And here's the thing, neither can we. We live in a world where this knowledge exists, where multiple countries have thousands of nuclear weapons, where the total destructive power stockpiled by humanity is enough to destroy civilization several times over, and we just go about our lives. We go to work, we watch videos, we make plans, and underneath all of it, there's this layer of existential terror that we've learned to ignore. But Oppenheimer couldn't ignore it. He carried it with him every day, and in some ways, his story is a warning about the cost of knowledge. Because not all knowledge makes you free. Some knowledge burdens you. Some knowledge shows you things you wish you'd never seen. And the secret of what happens when atoms lose control is one of those things. So next time you hold something solid, next time you touch a table or a wall, or another person, remember what Oppenheimer knew. Remember that solid is an illusion, that matter is just energy and drag, that inside every atom there's a tiny sun being held back by forces. We still don't fully understand, and remember that we figured out how to break those forces, how to make atoms lose their grip, how to turn matter into light and heat and death. And we can't undo that. We can't go back to a world where this isn't possible. And Oppenheimer knew that earlier than most, and it killed something inside him. And maybe that's the real discovery. Maybe what's really released when an atom loses control isn't just energy. Maybe it's also the realization that we're not safe, that the universe is more violent than we thought, that peace is fragile and destruction is easy, and that once you know how to do something terrible, you can never truly rest, because someone somewhere will eventually do it. And Oppenheimer died in 1967 from throat cancer. He was 62 years old, and in his final years, he was asked if he regretted his work on the atomic bomb, and he gave complicated answers. Sometimes he said he regretted how the bomb was used, but not the science itself. Sometimes he said, the physicists have known sin, and this is a knowledge which they cannot lose. Sometimes he just went quiet, and the truth is there's no good answer, because the bomb saved lives. According to some estimates, it ended the war with Japan faster than an invasion would have, and invasions would have killed millions, but the bomb also killed hundreds of thousands and poisoned the earth and started an arms race that still threatens humanity. And Oppenheimer was at the center of all of it. He was the one who made it real, who turned theory into practice, who showed that it could be done. And he lived with that weight for 22 years after the war, and it never got lighter. And maybe that's what we should remember when we think about what's released when atoms lose control. We should remember that it's not just energy, it's consequences, it's moral weight, it's knowledge that can't be unlearned. And Oppenheimer felt all of that, and he carried it alone. What would you do if you understood what he understood? If you could see inside matter and see the violence waiting there? If you knew that one decision, one calculation, one signature could release enough power to end the world? Could you carry that? Or would it crush you, like it crushed him? And if this video made you see reality differently, if you understand now why Oppenheimer looked so haunted in photographs, drop a like so I know this matters. Hit subscribe. If you want to keep exploring the physics that most people never think about, and comment which aspect of atomic energy you want me to break down next, because there's so much more to this story. Thanks for watching.